Okay, this is 3.8 chemistry. Which of the following is the net ionic reaction of a neutralization reaction? For those who don't know, neutralization, to make something neutral, how do you make it neutral? Acid plus base, right? And an acid plus base, any neutralization reaction gets you a salt plus a water, plus a water, plus water. Okay, usually the acid and base are both aqueous, okay? The salt is also aqueous, but the water is liquid. So if you want the net ionic, you remember net ionic, you only you only put in the net ionic those that change the state. Acid has H plus, base has OH minus, right? Okay, the the H plus turned into water is H2O. You guys know this. It was aqueous. It turned into liquid water, right? So would you put it in your net ionic? Yes. The base was OH minus, then it turned into liquid water. So would you? It was aqueous, turned into liquid. So would you put it in your net ionic? Of course you would, because it was aqueous, became liquid. Some people will say, oh, didn't H plus turn into H2O? How is OH also turn into H2O? My H2O, you guys know H2O is OH minus and H plus. Two H's, one O. And the plus minus cancels out to have the zero charge. Okay? So H plus and OS minus, they both change their state, so you both include them. And what do they change into? They change into H2O. So any any neutralization reaction has the net ionic equation that looks like this. Okay? Question 2. When a reaction between a weak acid and a strong base occurs, a something salt and water are formed. Obviously, if the base is stronger than the acid, then akid the salt formed will be basic, right? Because the base is stronger, so akid, how is the salt gonna be? It's gonna be basic as well. Yani it's logic. When a something and a something react together in equal quantities, the resulting solution is acidic. If the resulting solution is acidic, that means you had a strong acid, right? So strong acid. And if the acid is strong, then what about the base? It's gonna be weak, right? Okay. If an acidic is so if the solution is acidic, what does that mean? It contains more what than what? Every solution has H plus or H minus. Depending on the nature of the solution, whether it's acidic or basic, you will know whether there is more H plus or whether there is more OH minus. If there's more H plus, then it's acidic. If there's more OH minus, then it's basic. Since we said it's acidic, obviously it's going to be more H plus than OH minus. Okay? Question 4. Am I going too fast? Well, how many questions do we have? Oh shit, 6 questions. We gotta get this video to 8 minutes, guys. Well, no, I'll just, I'll put this with 3.9. The salt produced by the reaction of a strong acid and a weak base is what? Strong acid, weak base. So obviously it's going to be acidic. This salt will turn, what will it do to litmus paper if it's acidic? It's going to turn it from blue to red. صح? Question 5. When a strong acid and a strong base react in quantities that contain equal number of moles of H and OH, obviously equal H and OH, that means is it acidic? No. Is it basic? No. Then what is going to be? Neutral. Question 6. A neutral salt could be prepared by mixing a strong what with a strong acid? Of course, strong base with strong acid. They will cancel out and you get neutral. هلا 3.9. For this one here, this is 3.9 question 1. Which will react with water to give an acidic solution? Obviously, if you want an oxide to give you an acidic solution, then it should be an acidic oxide. This is a basic oxide, this is also a basic oxide, and this is also a basic oxide. So these will give you basic solutions. These ones, if you react it with water, you're going to get H2SO4, which is sulfuric acid, which is obviously acidic. And NO2 will get you HNO3, which is nitric acid, which is obviously an acid. So any acidic oxide, when reacting with water, will give you an acidic compound. Which of the following compounds react with water to give a basic solution? Akid, basic solution is all the basic oxides. CuO is a basic oxide, Na2 is a basic oxide. CO2 is acidic, SO2 is also acidic, SO3 is also acidic. Question 3. An aqueous solution of hydrochloric acid HCl is added to lumps of calcium carbonate CaCO3. Which of the following is an expected observation? Of course, when you add an acid to a carbonate, acid plus carbonate. What do you get? You get salt plus CO2 plus H2O, right? You get salt, carbon dioxide, and water. So, since we're getting a gas, CO2 gas, what's the observation? Bubbles. What are the products for the net ionic equation? Okay, for the net ionic equation, always look at this. Like when you're adding acid to a carbonate, you're always going to have water and carbon dioxide in the product. But how do we do it? I don't want you to memorize. I'm going to make it very easy for you. You have HCl, which is obviously aqueous, right? It was aqueous. Lumps of calcium carbonate. So you have CaCO3. Since he said lumps, what does that mean? It means solid. To get the salt, how do you get the salt? Box of the middle, CaCl. CaCl2 actually, because Ca2 plus Cl. It doesn't matter, whatever. But now what I care is the state. It's aqueous. And carbon dioxide gas and water, which is obviously a liquid, صح? Let's see. H was aqueous here. Here it was liquid. So that means we include it in our net ionic since it changed its state. Done. Cl was aqueous here. Cl is still aqueous, so we don't care about it. Calcium was a solid here. Here it became aqueous. So we're going to have Ca2 plus. And then here became aqueous, so we're going to put Ca. Hold up, wait. Calcium. Yeah, Ca. CO3 here was solid. Here it became a gas. So obviously we're going to include it. It became a gas, so CO2 gas. Here, CaCO3, we can just rewrite it as CaCO3 because calcium carbonate, to make matters easier. Okay, you're going to get H2O, CO2, and Ca. If they put for you Ca in the choices here, it would be correct, but they didn't. So what do we have in our products? H2O and CO2. They asked you to write this reaction in the Ca typing, I remember. Question 4. A student is asked to find the concentration of OH minus of a solution that's pH is 5.36. How do you find OH minus? You can find H plus because pH is equal to 10 to the power of, concentration of H plus is equal to 10 to the power of minus pH. So H plus here is going to be 10 to the power of negative a day 5.36. This is my H plus. How do I find OH? I just do 10 to the power of negative 14 divided by how much H plus? 10 minus 5.36. Let's see. 10 to the power of minus 14, 10 to the power of minus 5.36. You get this to three significant figures, 2.29 times 10 to the minus 9. Question 5. A solution is made by adding solid Na2O to water. What is the resulting solution? Na2O is a metallic oxide. Hence, it's a basic oxide. Hence, when you add water to it, you're going to get a basic solution. Write the equation for Na2O and water. Okay, it's very easy, guys. Na2O, obviously, plus H2O liquid is aqueous. Oh, no, sorry. It's solid Na2O. To produce, you're gonna have, you're gonna get a base, right? Na, what's the base of Na? It's obviously NaOH. Or you can just do it like this. Since it's a base, it's gonna have OH in it, so you're gonna put OH. And what's the metal you have? Na, so NaOH. And balance it, you have two Nas here, so you need to put two here. Check if everything's balanced. You have two O's, two O's, two Nas, two Nas, two H's, two H's. So this is your reaction, and obviously it's basic, so it should be aqueous. Acids and bases are always aqueous, huh? Question 6. HCl is added to a solution containing sodium acetate. Write the net ionic equation that takes place. So, apparently NaCH3COO is actually a base. It's a weak base. It's not an acid. I thought it's an acid, but it's not. Anyway, so when these two react with each other, I think, by the way, it's a weak base because it's a metal with some sort of oxide. So it should be basic oxide, but I think it's weak because anything containing CH3COO is weak. Anyway, from the question, they said strong acid, weak base. Like this, you can't see this, بس يعني. Just memorize NaCH3COO. Metal with CH3COO is like a weak base. Okay, so strong acid, weak base. Okay, they want the net ionic. Let's just write down the overall reaction and then see what happens. Obviously, HCl, you're gonna get a salt since you have an acid and a base. What's the salt gonna be? NaCl, صح? Okay, this is aqueous, by the way. This is aqueous. NaCl is a salt, so it's obviously aqueous. Plus, what's left? You have, we're done with these. So you're gonna get CH3COO, and then you just add the H at the end. CH3COOH, which is obviously aqueous. Let's see. What changes state? H, aqueous, aqueous. Well, I honestly don't get this. They're still all aqueous. I don't know. Ooh, let me ask ChatGPT. So this is what ChatGPT said. I don't really get what's happening here. Okay, basically said this. I mean, this makes sense. The sodium, okay. I think what they're trying to say is the sodium ions, Ne plus, and chloride ions are spectator ions because they do not participate in the actual chemical reaction. Okay. Do you not get NaCl? Hold up. Okay, so here in the overall equation, like we wrote down, over here, this was the overall equation. I think what they're trying to say is Na plus and Cl minus are spectator ions. Yani they don't really affect the outcome, but they are included in the overall. Okay. So I think they're saying yani it does like this Na and Cl ما غير شيء, but the whole reaction that's happening is the H with the CH3COO. That's why that's the net ionic. Honestly ما بحسهم بيجيبوا هيك سؤال. Like she wouldn't get something like this. بس يلا. Question 7. KOH is added to a solution containing ammonium chloride. Write the net ionic. Okay, this is a base. This is an ammonium salt. What happens when you add an ammonium salt and a base? You get salt, water, and ammonia gas. Right? Okay. Let's see. KOH, NH4Cl. How do you find the salt? Write down your equation. Box up the middle. You get KCl. What's you left with? NH4OH. What do we always say? It's a salt. For these types of reaction, you get water, H2O, and NH3, which is obviously a gas. This is aqueous. This is aqueous. This is aqueous. We want net ionic, right? NH4 was aqueous here, turned into NH3 gas. So are you going to include it? Of course, you're going to include it because it changed its state. You have here NH3 gas. Cl here was aqueous, still aqueous. We don't care. K was aqueous, K was still aqueous. We don't care. OH is aqueous, turned into water, which is a liquid. So are we going to include it? Of course we are. H2O, liquid. So it should look something like this. Question 8. كله right reactions. زائد reactions يا عمي. Okay, write the balanced reaction between calcium oxide and water. So this is a base and the water. You're reacting a basic oxide and water. So أكيد you're gonna get CaO plus H2O. When you're reacting a basic oxide with water, you're gonna get the basic hydroxide. So it should be CaOH. And you know Ca2 plus OH minus, right? Crisscross, you can get CaOH2. Okay? That's pretty much it. I guess you just put state symbols. They said calcium oxide. Okay. طب انت how are you supposed to know calcium oxide is solid? انا هلا I would have thought it's basic. It's wait, because it's metal. Yeah, okay. Basic oxide is metal oxide. Metal oxides are all solids. You should know this, Walid. I don't know why I don't know this. H2O is obviously liquid. It's calcium hydroxide. It's basic, so it should be aqueous, right? It's solid. Why is it solid? Why is it solid? طب NaOH wasn't solid, was it? It wasn't. Calcium hydroxide partially. Oh, It might be because calcium hydroxide partially dissociates in water. What is it, chemistry? I've been doing this since 1 p.m., man. COH. Uh, والله I have no idea. I guess memorize it. يعني خلاص calcium hydroxide is solid, guys. Calcium oxide and calcium hydroxide, they're solid. Okay. Then give the balanced chemical equation of dissociation that forms in water. So they want you to dissociate this. Okay. I think they asked this one specifically because calcium hydroxide, even though it's a strong base, it has a partial dissociation. So you put a double arrow. Okay. So it's going to be Ca2 plus and 2OH minus. Obviously aqueous. And we said this is solid. Calcium hydroxide is solid, guys. Question 9. But I actually wanted to ask ChatGPT, is calcium hydroxide always solid? Chop chop, bro. Okay. Okay. Calcium hydroxide is often found as a solid. Okay. Yeah, just memorize it, guys. How about calcium oxide? Wait, let's ask. How about calcium oxide? Okay, found in a solid. Okay, just stop. Pause. Whoa. Yo, ChatGPT. Okay, are metallic oxides always solids? Okay. Okay. Oh, whoa, that's a lot. Okay, what? Okay, what are the? Okay, basically the exceptions. We don't care about the exceptions. Okay. Yes, guys, I do use ChatGPT. Uh, I use it a lot, like most of the time. Almost every video I record, I ask ChatGPT something because, guys, it's getting hard to manage this alone. Wallah. Anyway, write the balanced reaction between sorry, before I continue, anytime you see a metallic oxide, just put it as a solid. Okay. These questions really they never come in our exams, but I'm still doing them because you have to know them. I guess at the end of the day, write the balanced reaction between sulfur trioxide and water. It dissolve SO3 and water. Obviously, this is acidic, so obviously it's gonna be an acid. And then you're gaining an oxygen and H2, so obviously you're gonna get H2SO4. How I think of it really, when you're working with acidic oxides, I just add an O, SO4, and which acid has SO4? It's just H2SO4. Okay? Obviously the acid is gonna be aqueous. Give the dissociation of H2SO4. H2SO4, remember this is one of the exceptions. Even though it's strong, it has a partial dissociation. Why? Because it's H2. Diprotic acids all have partial dissociations. Because look, the first dissociation, look. The first dissociation, we did this in a previous section. I think it was 3.7. The first dissociation will look like this. Because remember, you can only dissociate one H plus at a time. Aqueous. This is the first dissociation. Okay? But is it dissociated fully? No, it still has an H. But now we have this HSO4 that contains a H plus in it. In chemistry, an acid is defined as anything that can lose H plus. Since this one can lose H plus, it's also considered an acid. But do you think it's strong? And you look at it, it's not strong. So that means it will have a partial dissociation. My dad says it's a waste. Okay, Nikid, aqueous. But my point is, you can't say it has a complete dissociation and put a single arrow for H2SO4. Because like here, they want you to basically like wrap it up, go from start to finish. Okay? You can't say it has a complete dissociation. Why? Because the second one had partial. If the second one had partial, then in general, when you talk about H2SO4, even though it's a strong acid, it has a partial dissociation. Okay? 2H plus, and SO4, 2 minus, aqueous, aqueous, aqueous. Okay. Question 10. Write the net ionic reaction between sulfur trioxide and sodium hydroxide. Acid, base. What do you get? Salt and water. Acid, SO3, base, NaOH. How do you get the salt? What do they want? Net ionic? Okay, wait. See here, especially for acidic oxides, okay, you have to learn this, okay? For acidic oxides, basic oxides, let's say مثلا you're reacting like remember we have HCl plus CaO. This one it would be easy. You'd get CaCl2 plus H2O, water, whatever. This is easy stuff. But here, when you have an acidic oxide, it's different because acidic oxides they don't react on their own. When you're reacting these two, you know NaOH is aqueous. Aqueous meaning it's dissolved in water. When you dissolve SO3 with the NaOH, which is in water, there's actually stuff happening behind the scenes. When you're dissolving it in NaOH, it's actually in water. You're technically dissolving SO3 into water at the same time. And when you do that, you get H2SO4. Okay? So the acid you're going to use is H2SO4. So, I don't confuse you guys. Anytime you're reacting SO3 or any acidic oxide for that matter, any acid with a base, you're not allowed to use it as SO3. You don't. Okay? You have to dissolve it in water. Okay? Think about what happens when you dissolve it in water, you get H2SO4. حتى let's say مثلا they said CO2. Let's say CO2. CO2 gas. Okay, this is acidic, this is basic, but you can't use the CO2. Dissolve CO2 in water. What do you get? You get H2CO3. Or HCO3. What was it? H2. You get H2CO3, which is hydrogen carbonate, which is carbonic acid. This now can react with the base. So it has to properly turn into an acid with hydrogen. You're not allowed to use it in its gaseous form just like this, okay? So here SO3 will turn into what? H2SO4, right? And now you can actually proceed with the reaction. H2SO4 plus NaOH. What do you get? Box up the middle, NaSO4, which is wrong, but you have to say Na2SO4 because it's Na plus and SO4, 2 minus. Crisscross, you get Na2SO4. Obviously, it's aqueous because it's a salt. Plus, you get salt plus water. Acid plus base is salt plus water. Okay. طيب. Now we have NaOH aqueous. This here was aqueous. But remember, were these my reactants? No, they weren't. My reactants were these. So you have to rewrite it like this. We actually had this. Okay, let me just give me a sec, guys. Na2SO4 aqueous plus H2O liquid. So this is your reaction. Now, can we find the net ionic? Of course we can. SO3 was a gas, it turned into SO4, which is aqueous. So you're going to write SO3 gas turned into what? SO4 2 minus. Right? You write down the ion, you don't write down the compound, you only write down the ion. Okay, this is aqueous. Let's see what else. Na is Na, they're still both aqueous. OH was aqueous, became a liquid. So we're going to say OH minus, aqueous, and liquid H2O. Some people they might tell me, you said you only write down the ion. Why don't you just take OH out of this and say OH liquid? No, Habibi, that's not how it works. Okay, for OH and H plus, you have to say H2O. Okay? طيب. Question 11. Okay, you have an unknown solution whose pH is 4. Obviously, if its pH is 4, then it's acidic. And then they say a concentration of H plus. You know, concentration of H plus, if you're given the pH, is 10 to the power of negative pH. In this case, it's just going to be 10 to the power of negative 4. You don't even have to calculate. And then they say how much is OH. How do you find it? You just do 10 to the power of minus 14 divided by your concentration of H plus, which is 10 to the power of minus 4. And you're going to get 10 to the power of minus 10. You don't even need to calculate this. You know, you can do it in your head. Question 12. Okay, the dissociation of potassium nitrate is an endothermic process. They told you it's an endothermic process. So during the process, the temperature obviously decreases, guys. Potassium nitrate is KNO3. Okay, and the pH of water in which it is dissolved is going to be equal to 7. Because potassium nitrate, it's like, is it acidic? Obviously, it's not. Don't have H. Is it basic? We don't have any. Like, this isn't a base or an acid. It's just a neutral salt. Why would the pH change? These trick questions, they ask you a lot. Endothermic, أكيد the temperature decreased, but the pH will not change. I don't have an acid. I don't have a base. It's just a salt. Question 13. A solution is made by adding sulfur trioxide to water. Sulfur trioxide is this. Okay. What will the pH change from? Okay. Water is pH 7. So obviously pH is 7. You want to see, is it going to be, are you adding an acid or a base? SO3 is an acidic oxide. And by the way, when you add SO3 to water, it becomes H2SO4. صح? So it becomes a very strong acid. H2SO4, we know it's a strong acid. Even though it partially dissociates, it's a strong acid. So, is it going to change to 14? Obviously not. That's basic. 12 is also basic. So, we need it to be acidic. So, it has to be less than 7. The only one less than 7 is 1. Question 14. When solution is added to something, carbon dioxide gas will be produced. Carbon dioxide gas will be produced, meaning you have a carbonate. So, you're adding something to a carbonate. What is the reaction that gets me carbon dioxide gas? Acid plus carbonate, right? So, obviously, I need to have an acid here. HCl is probably the only acid. It has to be a strong acid. You're adding it to a carbonate, so it has to be something with a carbonate, metal carbonate. بصراحة مالي خلق افتح الكويز. But anyway, you choose the acid plus the metal carbonate. Easy as, guys. Question 15. When KOH solution is added to something and the mixture is heated, NH3 gas will be dissolved. When will you have NH3 gas? When you have a base plus ammonium salt. What's the only base we have here? This is acid, acid, acid. No. We want KOH is the base, right? طيب. And which one's ammonium salt? The only one with NH4 and is NH4Cl. Question 16. It's our last question of chapter 3. Alhamdulillah. When KOH solution is added to AlCl3, what is formed? How do you find the precipitate? You have a base and you have yeah. You have base and you have AlCl3. If I'm not wrong, this is amphoteric, صح? What is this? No, wait. Hold up. Man, no, it's one way. Was it 9? Yeah. Yeah, it's amphoteric, so it can act as an acid and a base. Okay, even though I said Al2O3, but it doesn't matter. Or no, was it Al2O3? Oh. So I don't really know why. It's a salt. This is a salt. This is a base. Okay. They want you to talk about the precipitate being formed. If a precipitate is being formed, that means what method are you using? Precipitation method. And to do that, you're mixing two soluble aqueous solutions. KOH is obviously soluble, it has K. And AlCl3, it's soluble. Cl is always soluble unless it's mixed with Ag, Pb, or Ba. صح? Let me check. Yeah, AgPb, but SO4 is BaCpB. Okay, that's something else. So these two are soluble. So you're gonna get an insoluble precipitate. But that's not my point. Here they're asking what is a precipitate. Type KOH AlCl3. If you box up the middle, you get AlOH. Can you leave it like that? No. Al is 3 plus. You can tell كمان since Cl has a 3 subscript, that means the charge of Al is obviously 3 plus. OH, you guys know OH is always OH minus. If you crisscross, you get AlOH3. That's it for chapter 3. This is my last recording of chapter 3. Thank you so much for watching. Good luck in your exam.